If you haven't done so yet, please pause the video and try to solve the question on your own before listening on. What we want to do is draw a free body diagram that shows all the forces acting on the boom. Starting at the top of the boom, we have the weight whose gravitational force is pulling down at the very end of the boom. Notice that we converted the 2,000 newtons for that weight into kilonewtons. Moving down the boom, we can see that there is a second force acting on it, and that is the tension in the rope. Perhaps you can see that better by looking back at the diagram, but it is this tension that's pulling the boom in this direction that's actually preventing it from coming crashing down to the ground. So we've shown that force on our free body diagram, and we've labeled it T for tension. Notice the angle was given as 25 degrees. Then we get to the center of the boom, and at that center, we would have the gravitational force or the weight of the boom itself. Again, we converted that into kilonewtons. Finally, we get down to where the boom makes contact with the ground, and there are two forces acting there. There is the upward force that the ground is exerting on the boom, and then there is this horizontal force that's projecting to the right. If you weren't sure about that horizontal force, where it's coming from, and also the direction of it, try to imagine the ground right here, and then a object, such as a boom, pushing its way into the ground. Now, we can see that that pushing force into the ground is broken up into a horizontal component that would point to the left and a vertical component that points down. So really, that pushing force into the ground can be represented by these two components. Now, since the boom is pushing itself into the ground, in response, will push up on the boom and also to the right. It's actually a reaction force that the ground is exerting on the boom. So that's where the rightward horizontal force is coming from, and the upward vertical force that we've marked in the free body diagram. Now, we're going to choose a pivot point at the bottom portion of the boom, and the reason we choose it there is because these two forces, which are unknown, will produce torques equal to 0. So we can exclude them from the equation that we're about to apply. We're moving on to the sum of the torques equaling 0. And so we're going to exclude, again, these two forces because they pass through the pivot, and therefore their torque will be 0. However, we will include the forces circled in green in our torque analysis. Let's not forget that torque is equal to the force multiplied by the distance multiplied by the sine of the angle. Now, the forces as well as the distances have been marked. Note the distances. Now, as for the angles that we're going to be using in the torque equation, we want the angle between the force and the boom. And so what it might be helpful to do is to extend a line straight down so that we form a nice right triangle right here. And we can see that if this angle is 65 degrees, then this angle right here has to be 25 degrees. And the same reasoning would conclude that that angle is 25 degrees. Notice that the angle between the tension force and the boom is just 90 degrees. So take note of those three angles. We're about to use them in the torque equation. Also notice that the two forces circled here and here are both tending to cause the boom to rotate in a clockwise fashion, so those torques will be negative. We'll note that the tension force is causing the boom to rotate in a counterclockwise fashion, so those torques will equal a positive value. Notice that L appears in all three terms on the left side of the equation, so we can basically divide out the L, which means that it's going to cancel from all of the terms. We could then pick up our calculator and simplify this term minus that term. We can also simplify 3/4 times the sine of 90. So then we could add the 1.099 over to the right side and then divide by 0.75, and that's going to allow us to solve for the tension T, which turns out to be approximately 1.47. And notice that the unit will be in kilonewtons as opposed to newtons, because we had converted the forces from newtons into kilonewtons. So this would be the correct answer to part A of the question. Now, to find the force that's marked H, we need to note that the sum of the forces in the x direction is equal to 0, since the boom is in equilibrium. We'll notice that there are two forces acting in the x direction. There is the H force, and then there is the horizontal component of the tension force, which is projecting to the left. We can see that that component will be T times the cosine of 25. So in the sum of the forces, we would have the positive H force minus the T cosine 25. Notice it's minus because it's pointing to the left. Now we can add the T cos 25 over to the other side, and then we can easily calculate this horizontal force because we just figured out the tension. And if we plug that into our calculators, we get approximately 1.33, again, kilonewtons, and the direction of that force is to the right, as we had originally drawn. And now we can calculate the force that's marked V, because we know that the sum of the forces in the y direction is also equal to 0. We have the V force acting in the y direction. We have this force in the y direction. This is also in the y direction. And then notice that there is a y component of the tension. It's a little bit hard to see from the diagram, but it would be pointing upward. And we can see that that component would be T times the sine of 25 degrees. So that's also going to be a force in the y direction. Notice that this force and this force, because they're pointing downward, have been given negative signs. So we can go ahead and plug the value of tension in. We'll collect these like terms and then move them over to the right-hand side. And we can see that V is approximately 2.58 kilonewtons, and the direction would be upward. And so that's the correct answer for V. Thanks for taking the time to watch the video. If you liked it, please click the thumbs up icon and also subscribe to the channel so you can stay tuned for additional videos. Remember, you're welcome to send in your own question to this email address, and I'll do my best to post an answer to it.